I would like our discussion to be like a bit casual. So I'm going to let you introduce yourself in a moment, but I'd like to start by saying that the goal of this discussion, of this video, is mainly to talk about your book, AIX, Artificial Intelligence Needs Explanation. So the book is available on Amazon, and I'm going to add the link in the description section of the video, like down below. And so I do advise everyone to check the book. And I read the book like 2 months ago, and I did love it. Actually, I was looking for a technical book, and I was just looking for a book on Amazon, and I found your book. And your book is much more oriented towards business managers and business in general. But I did love the book as it did give me that vision. I mean, it did bridge the gap between vision of data scientists and business vision, business standpoint. So I thought it was truly interesting. I did want to share that experience with everyone, with all the viewers. So I'm going to start by asking you, you started working in the field of AI in the late 90s. So can you please just introduce yourself and tell everyone how did you get into this field in the 90s, and what was it like to work in this field back then?
Yeah, so I was 17 and I had to choose after my high school for university. And I couldn't choose. I liked everyone. I liked mathematics, psychology, philosophy, biology, language theory. And then there was this study combining everything. And I thought that's really great. And then on top of that, how did I get across this topic? Because no one knew about artificial intelligence. What's that? My parents were worried whether I could find a job with such a strange study. So how did I come across it? In high school, I had a course in philosophy, and the examination topic was called Man or Machine. And actually, I have the book here. It's in Dutch. And when I wrote my last book, I checked it out again. And because here, in 1986, they already said, well, the human brain is really something very different than a computer. But what can we learn from the analogy? And I really like that way of thinking.
I'm sorry to interrupt you. What name of the book?
This is a Dutch book, and it's also written by a Dutch person. And the name is Man or Machine? ?
Okay. No machine. Okay.
Yeah. So this is how I got to know that there was something like people thinking about artificial intelligence and neural networks, what they then named connectionism. So I already learned a little bit about that through my high school philosophy exam topic. So then I started with this study, and everything was new, and no one really knew what it was, and even our professors all working in one pillar of the education system, while we as students followed courses from different disciplines. That was very interesting. We really had to make our own program in some sense. And I really liked it. It was difficult, but I liked it. And then this diversity, I think it's a theme in my whole life. So when I graduated, I wanted to work in a commercial organization. My first job was a consultant. We created expert systems, and it were expert systems for many different industries. So from insurance and banking to harbors, it can be anything. And that diversity, I liked it a lot.
So we're going to talk about the decision support system in a couple of minutes, but I would like to ask you one question that comes so often to my mind, is that I've been working as data scientist for like a couple of years now, and there's a question that came back so many times in my discussion with my fellow data scientists, is that I get this feeling that there's a quite good number of projects in IT or in AI in general that fail, whether it is because they don't meet the needs of the client or so many other reasons. So now you have something like 20 years of experience in this field. I would like to ask you, when clients comes to you with some kind of problem that they would like you to solve, like what are the steps that you follow? How do you go from having the problem at hand to establishing some solution that would work for your clients and that would meet the needs they have?
Yeah, I always start with definitions, and this is also in the 6 steps method that I propose in the book. It's so important to understand the basic concepts in a new domain. And I start, for example, working for an airport, and they ask me, how can you do that? Because you've never worked for an airport before. But what I do in the first 2 weeks is gathering all the concepts and write definitions. And then doing so is so important because even my customer learns from me writing down the definitions. And then I create context. I always try to find out what is the question behind the question of the customer. Yeah, I need to make it first broader to understand the context. This is really very important because the business value is always in this bigger picture. You need to see the bigger picture and define the concepts very well, because knowledge, in my opinion, it's understanding the right words for the concepts, and understanding the relationships between these concepts.
Yeah, I mean, I see this a lot in industry because so many data scientists I know, they just try to solve the problem while sitting in their cubicle in an isolated manner without really trying to communicate with the experts in the field.
Yeah.
I think this is one of the problems that we face, for example, in AI. And we've seen this lately with coronavirus. A problem is that so many people are trying to resolve the problem while they don't have any relationship with medical experts or experts in the field of medicine. And this is quite a big problem that we have in this field. And when you say that we have to start from the basics, from definitions, understand what the words mean, and then move on to understanding the need of the client, I think this is truly important in our field today. And so what I would like to talk...
Understand the structure of the domain. So you don't need to become an expert yourself, but you need to see the structure.
Yeah, I think this is quite necessary for solving any kind of problem in artificial intelligence. So now I would like to move on to the topic of your book, which is Explainable AI. I mean, I hear so many definitions out there in the world, but I would like to understand what do you mean with, what does this expression mean for you, explainable AI? What do you mean when you say this?
Yeah, so let's not start with another definition, but this time let's look at the process around it and the context.
Okay.
So for me, explainable AI is an AI solution which is doing something smart, solving a task that normally was done by a human. But doing it in such a way that you add real value to the solution by making sure the users, the people that use the system or that interact with the system, understand how it works. So the results, they should be explainable for these users. The user should just believe that he really understands how the system works. And then also there should be a known mechanism how to collect feedback from the users or the people that use the decisions, and to make improvements. It's very important that there is a feedback loop so the system can be continuously updated. Because the thing is that the world is not static, while a programmed computer is still pretty static.
So when you say the user, do you mean like business managers having some kind of interface, or rather data scientists being inside the loop and trying to follow, to see if the model, for example, is biased or why it is deviating? So which one are you
Well,
talking that?
that really depends on the industry. The user can be a citizen, the user can be a business manager, the user can be a administrative person in an organization, or as you suggest, a data scientist.
Okay, so this one common belief that we hear so much in industry is that what we commonly call black box models are so good when it comes to predictive power, like when it comes to making predictions. And there are models that are, for example, rule-based systems that are less powerful when it comes to making predictions. And so you talk about this idea that we, like people industry, should make some kind of hybrid model, like a combination of the two of them in order for the model to be successful in the real world. So what do you mean when you say hybrid model, and why do we need to do this?
Well, I think most AI systems are already a hybrid model.
Okay.
Because all these trained algorithms, they use data, and the data is often not the raw data, but the data is prepared. There is a process called feature extraction, and typically in feature extraction you already use knowledge and rules to prepare the data and make it better suited for the algorithms. So there is always a little bit of rule-based, heuristics-based pre-processing for these algorithms. Now, what I propose is that you don't only do a pre-processing, but also a post-processing, where you analyze the results of the model and the factors that contributed most to the decision. You understand what it means for a user to have a good explanation, and you use that to explain to the user how the model came to a specific decision on a specific case.
Okay, so I think one question that comes to my mind so often is that I don't know whether you did think about this, but so many companies just try to use like the latest models that are very powerful because there are no laws that exist or no law framework that exists today to impose like the large companies to use models that are explainable. Like if we take as an example a model that would predict if we can give a loan to someone, for example. I mean, there's no law that exists that imposes on banks to use models that are explainable.
There are some laws.
Okay, I didn't know this.
Because there is a law that says that every life-changing decision should be explainable, and also people can ask for a human eye, where someone needs to look at the case and check whether the decision makes sense. And for example, providing a loan, for example, for a house is a life-changing decision.
Okay, so I think I can think of so many other examples, and you talk about this in your book, for example, recommendation systems impacting people's choices, and so many other examples that we can see in our life in general. But when you talk about explanations, like what do you think of as being a good explanation? Like what can make of an explanation a good explanation?
Yeah, that was really very interesting research that I used for the book, because a good explanation is not necessarily, for example, a full listing of all the rules that have been involved in making the decision. That's just too much.
Okay.
A good explanation, actually, it should be believable for the user. It should make sense. It should be relevant. It should also list the distinguishing factors. So not only the factors that contributed to the decision, but also how it can be distinguished from probable other outcomes.
Okay.
And then it should not be too complex, because if it is overly complex, it doesn't work. And I use this diagram. Maybe you... Oh.
Yeah, we don't see the book. Can you just please shift the book a bit? Yeah, I can see it right now. Yeah.
Yeah, you
Okay.
remember that diagram where we say, well, a good explanation, it is believable, relevant, distinguishable, and then divided by complexity, because if it is too complex, it doesn't make sense.
Yeah, the more complexities, it's
Yeah,
going to
yeah.
overwhelm the user, and
Yeah.
she or he is not going to truly get the gist of it. Yeah, so I would like to go to one technical aspect that you talk about at the end of the book, but I would like to ask you, you in terms of your preferences, what do you prefer? Do you prefer to use like an explainable model that makes use of so many hypotheses, for example, or rather like a very strong model that, and then try to explain it at the end? Like once you train the model, you try to use tools that aim to explain this model. So in terms of preferences, do you prefer simple model that is self-explainable, or rather a model that is quite complex and then explain it at the end?
Well, I said in the beginning that I always look at the context and try to find the question behind the question. So it will be difficult to give a general answer without knowing the industry and the users, etc. But the benefit of having a separate explanation model is that you can target your explanation at a specific audience. So you may have the naive user or the citizen wanting a general explanation that is a little bit different from the expert or lawmaker itself, who wants to understand very specifically which law articles or which data has been involved. So that's the benefit of a separate explanation model, that you can have multiple explanation models targeted at different kinds of users.
Yeah, so I usually, when I try to explain, like when I use a model and try to explain it, I do it in order to see if there are any biases that are included in the model or in the data that I use. Can you think of other usage that we can make of like such explanation tools or that people use in industry?
Yeah, well, one thing is to correct the system. So if you get a recommendation on a website for a product and you understand that the recommendation is because you bought a specific book for a friend, but actually it's not a topic that you like, so it's not a recommendation for you, you can provide feedback and correct the system by saying, well, that recommendation is, I understand how it comes about, but it's not good for me.
I have one other question. That is, so when you have problem that you're trying to solve, how do you decide like whether you're going to go for a rule-based system or machine learning system? Like, how do you make that decision?
Yeah, well, I believe a rule-based system is always preferred above a data-driven system when you have knowledge, when there is expertise, when you are able to make it explicit. If not, you need, of course, to question whether you have the right data. So you really need to understand the issue at hand. And also you need to have a very good mechanism when the system needs to be updated. So for example, the case at the airport where we predict the number of people at the airport, you can imagine that in the whole COVID-19 situation, well, this model is irrelevant.
Yeah, it's rubbish. It's totally irrelevant. Yeah.
So you are back again to the heuristics and the knowledge-based systems, where you know that certain flights have certain arrival patterns. But yeah, so knowledge, I think it's always preferable. If you can make rules, you should prefer that. Yeah.
Okay, so your go-to system is basically a rule-based system, and then you try to complement it with some kind of machine learning. So Yeah.
And of
So,
course, there are many domains in which it is impossible to collect in a lifetime all the rules, well, to detect some forms of cancer, or so there are many situations where it is impossible to collect all the rules, and a database approach is a very good alternative if you have the right data.
yeah, and there's one other thing that I can think about, and is that I don't know if you know Judy Appel, who is a guy who works on causal inference, basically causal models. And what he says at the beginning of his book, The Book of Why, is that we as human beings, we evolved to have some kind of causal thinking. I mean, we have our own biases, but we have some kind of causal thinking. We can just make up so many scenarios in our mind and think about the very beginning and what would the consequences be at the end. I think this does give some kind of power to rule-based systems, which are based on the experts of like knowledge of experts. I think this is one bonus point for rule-based systems over machine learning. Yeah, so I would like to ask you one final question. So, if you were to give some guidelines to companies or to teams, like on how to use all these systems, how to go about explainable AI, so what would you suggest? What are the guidelines that would you propose to implement explainable AI?
Well, first of all, there should be awareness across everyone in the team that having an explainable system adds more value. It will, in the end, in the long term, have a better return on investment. The system will be more trusted. It will be easier to update the system with new knowledge. And also, the system will be more ethical and better prepared for eventual legislation or guidelines from governments about the use of AI. And that awareness, I think, is the starting point for every project. Then, if you have all the stakeholders aligned with that awareness, it will be much easier because end users will look at the system and ask the right questions to get to an explainable model. And of course, having all these stakeholders involved, well, in many cases, this is still lacking in IT projects in general, and also in AI projects. Actually, in many AI projects, it's even worse because AI is also difficult and no one understands it except the experts, the specialists who studied artificial intelligence. And that can never be true. I very much like the saying from, who was it? If you can't explain it to a 6 years old, then you don't understand it yourself.
Yeah. Yeah, I think that would be a very good conclusion for our discussion. Thank you so much, Silvie, for joining me for that discussion. I do encourage everyone to read your book. I think it is very interesting, like to have that business standpoint and see how like stakeholders, business managers, project managers, like some less of technical people see this and what would be the benefits for them to implement explainable AI systems. And that would be very interesting even for data scientists, as sharing this vision is very interesting within company or within team. So thank you so much. I hope you've enjoyed our discussion. I did enjoy it so much. So thank you, and maybe we can have another discussion later.
Yeah, thank you very much for your invitation.
Well, you're welcome. Have a good weekend. Thanks.
Yeah, you too. Bye-bye.
Goodbye. Bye.